At the end of 2020, when we were forced to spend our days in solitude because of this pandemic, Spotify did something amazing. They wrapped everything the users listened to in the year and gifted it to them as a memorable journey to look back on. All my favorite artists, genres, tracks, podcasts, and songs that I don't even remember listening to showed up neatly packaged in a playlist. Honestly, it was not the gift I was expecting to receive at the end of the year, like my year end bonus, but it did lighten my mood. The data engineers at Spotify called them data stories, and I must say they named it quite aptly. The songs were like snapshots of my memories for the year 2020 in retrospect. Hi, my name is Vaibhav, and I have a total of 16 years experience in tech. I am most passionate about repurposing organizational data to drive interesting data products. Today, we will talk about Spotify's Wrap campaign and how they managed to pull off collecting data from millions of users around the world. During the early 2000s, there were two kinds of music buffs. One kind was listening to music on iTunes, while the other kind was, downloading it off random websites. Although using iTunes was the more ethical option, but you had to pay and download every song you wanted to listen to. And when you think of the target audience, of which a major share would be broke college students, paying for every song was not the most feasible option. But in 2008, the scene changed when an audio streaming platform called Spotify was released. Users of Spotify did not have to download music anymore. They could stream it. Additionally, they also offered multiple subscription plans that the people could take depending on the size of their wallets. Now, people could listen to any song they wanted at any time without the hassle of downloading it. Today, Spotify has over 165 million paid users. That's right, 165 million paid users. Their competitors like Apple and Amazon combined have around 105 million premium users tentatively. That's a lot of users, which in a way means a lot of data. And collecting data from these millions of users to design the wrap feature is no mean feat. Needless to say, the data engineers at Spotify had to work hard to make sure that they didn't miss the beat on building this record. So, what did they do? They built a system called Data Pipeline. If you are imagining a water pipeline, you are not far off the mark here. The concept is pretty similar. Earlier, people would go to a water reservoir to collect water and then travel all the way back to their houses. But now, with the help of systematic infrastructure, water automatically flows from the reservoir through the pipelines and out our taps whenever we want. The system designed by Spotify is similar. Instead of manually collecting data from each user, Spotify built an infrastructure that can automatically store and fetch your data whenever you need. They use Google Cloud Storage, BigQuery, and Bigtable to store the data. These technologies act as a reservoir, but instead of water, they store your data. Now we know where the data is stored, but how exactly it is collected? Usually, a good ETL tool is used. Well, what is ETL? It's a process. A process that an ETL tool performs has three functions. It first extracts raw data from different sources. Once the data is extracted, it's transformed into the standardized format. Finally, the data is loaded into a data warehouse ready to be used whenever needed. Traditional ETLs like these are good enough to process data for smaller companies. They usually tend to collect batches of data at regular intervals depending on the need and use. Then ETL tools will process them and make them available for usage. But this system doesn't really work for large companies like Spotify that deal with having to collect and process real time data. In this case, the data produced by the sources are ephemeral in nature. The data is available only for a short period of time, and that has to be processed as quickly as possible. Moreover, the flow of data is continuous and unstructured. Play requests, like tracks, and personalized playlists of millions of users are processed in real time. Traditional ETL pipelines will take more time and resources to transform this humongous pile of data. Sometimes the ETL pipeline might even break down and the data is lost. Thus, it is important that the ETL tool is able to accommodate these needs. So, how did they fine tune the pipeline? An open source framework called Apache Kafka was integrated into their ETL pipeline. Kafka acts as a buffer. It decouples the source system from the destination systems. It essentially acts as a middleman and becomes the destination for the source and the source for the destination. In this way, the load on ETL pipeline is eliminated. The latency of data processing in Kafka is less than 10 milliseconds, which means within 10 milliseconds, the data will be extracted from the source, formatted, and sent to the destination. Isn't that amazing? The extracted data from the source entering the Kafka cluster will be in key value pairs. Keys are user ID, song name, artist, genre, streaming time, etc. And the values are each individual names of the keys of that particular song. Like, let's say the key is song name, then the value might be blinding lights. A Kafka cluster will have multiple brokers, and each broker acts as a separate server. To manage all these different servers, Kafka uses a leader selection system called Zookeeper. It's like a supervisor keeping track of all the brokers and the data in them. If one of the broker goes offline, the zookeeper makes sure that data in that broker gets replicated in another broker which is online. From Kafka, the formatted data is loaded to Google Cloud Storage or Bigtable. Apart from the latency in data processing pipelines, there were a few other obstacles they had to clear. Spotify used to process all this data in Hadoop offline cluster. Hadoop had 2500 nodes, which are nothing but the data storage and requesting units in a cluster. What this cluster mostly did was to chunk or split datasets into smaller pieces that were then processed for applications like ad targeting, weekly recommendations, playlists, and artist suggestions. You get the idea. As the users increased, Hadoop cluster was running out of physical space. So Spotify had to migrate its clusters to a cloud for scalability. Google Dataflow is now used to run these processes. Since they shifted to a cloud, they needed an efficient API to request the aggregated data from Google Dataflow. So they just built one called CO to suit their needs. APIs basically help connect two systems, kind of like a mailman. CO is inspired by Apache Spark, which is an analytics engine. It is used to handle most of the server-side processing. Like Kafka, CO can be used for both batch and stream processing. Now that the data is collected and stored in the most optimal way, the next step is to use it. Spotify used the data and weaved them into stories, which they called wrapped campaign. Using CO, they pulled the data from Dataflow, post which it was aggregated into different data sets like top artists and top songs, and then they added more data. The additional data contained information like the first stream of your favorite song of the year. This demanded extra effort as the program will have to dig into the archives to find it. The next job is data enrichment. Enrichment involves improving the quality of the data, and this is achieved by simply adding more data into the mix, such as album covers, artist images, and graphics. They also filtered users that are eligible for the wrap campaign. New users that used the app for 3 to 4 months were not eligible. All these stories were stored in Bigtable and sent out to the users at the end of 2020. The users could then unwrap their stories of 2020 and listen to their top songs, play to some colorful graphics. Spotify Wrapped feature will continue to unfold year on year. Engineers at Spotify are constantly working on optimizing these virtual pipelines to make sure we end our year on our favorite melodies.